I spent a year designing and building stop-motion rigs. Could I build one using only hand tools, a $6 helping hands, and some 3D printed parts? At least that's how it started. Then it ran a little bit out of control. When doing stop-motion animation, you often need some way to hold the thing you're animating. Whether it's teetering on two legs or flipping through the air, you really need some sort of system to hold the parts in place. This is called a rig. And professional animators use all kinds of different rigs, many with ball and socket joints or special rack gears to help them move the characters and parts around during their animation. I thought it'd be super fun to build some rigs like that. Now, in my animations, I have used a few little rigs, but they're usually just sad pieces of armature wire, and they would be embarrassing for you to even see. And I love a design challenge, so challenge accepted. Now, it's important when doing a design to give yourself a bunch of limitations. Now, I know that sounds a little funny, but the truth is, if you say, oh, you can take any amount of time, use any materials, do anything you want, you have no traction, you have no way of making any decisions, you're paralyzed. The more limitations you give yourself, the more of a landscape you give yourself to navigate through. You can make decisions, you can decide on stuff. It gives you a nice way to make progress and evaluate how you're doing. So always give yourself a bunch of design limitations, even if you don't need to. That really helps foster creativity. All right, so what are our limitations? One, I'd like to make this thing largely out of 3D printed parts because a lot of people have access. I can share the designs, I can iterate, so that's great. Secondly, I don't want to use a lot of power tools. I mean, I could use a lathe and a ball turning attachment and make all kinds of crazy stuff, but frankly, that's not a great idea. Because one, nobody else can do that, and two, I want to make a bunch of these things and not spend all my time machining a bunch of custom stuff when it'd be better to be hacking this out of readily available materials. I'd also like to make it be designed largely using parts from a $6 helping hands. Now, I don't know if you've seen one of these things, but they're basically for helping you solder parts. I've had one since forever, and they're a cheap source of ball links and bits of hardware, so that's at least a place to start. Also, I'd like to make one that has a rack gear. Those are called winders in the industry, and none of my existing rigs have had that, and I think it would be very handy for doing precise vertical or horizontal positioning. So, and gears are fun, so let's incorporate a rack gear. And finally, I want the thing to look like a cute robot, because why not? And if I'm going to be designing these things and having a bunch of them around all the time, I want them to be fun and cute. So what comes with one of these helping hands? Yeah. So with all those parts in there, you basically get a bunch of ball end links and some clamps and two alligator clips that form the helping hand system. Now, to make this rig more useful, we really need a nice heavy bass. Ba-boom, boom, boom, ba-boom, boom, boom, ba-boom, boom, boom, boom. No, not like that. I mean a bunch of mass at the bottom to keep it from tipping over while we're using it. Huh? Oh. No, 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 no. I was using nickels because they were a uniform source of weight. It wasn't until I tried to get some that I realized we were in the midst of a coin shortage, and banks were not giving out rolls of coins to just anyone anymore. So my wife had to put out a call, and I had to play reverse tooth fairy and go around to various houses picking up coins that people had left out for me. In order to build a precise rack winding system, though, we're going to need some tiny axles and bearings, which means I think we have to talk about brass tubing. Like, I love it in a you may have made some wrong life choices kind of way. Because the tubing nests, you can use it as inexpensive plain bearings. Now, ironically, the worst way to cut brass tubing is with a tubing cutter. These are terrible because this crimping action as they cut narrows the tubing down enough that it no longer nests. That's more than a simple burr. Before doing any cutting, though, it's important to clean up the outside edge of the tubing. This is going to form one of the edges of the part, and it's not going to get any easier to hold on to. So how are we going to cut this tubing? I have serviced no kings, yet I would wager I can cut brass tubing with 10 times the dexterity of any street tubing cutter. This is an inexpensive razor saw with 54 teeth per inch. Even with these super fine teeth, it's hard to keep 3 teeth engaged in this thin tubing. So I arc around the top to keep a lot of teeth engaged for as long as possible. Then once I break through, I stop and I use the next smaller size of tubing as a cutting guide. This also lets you cut all the way through the tubing before it disconnects. And it keeps the part from falling and getting lost forever. It also gives you a way to hold on to the tiny new part and clean up the burrs on the other side of it. Dang it.
Now, we all know there's only one size of this tubing you can hold on to. With nested tubing, I can handle even those difficult smaller sizes with complete safety. No more workplace injuries for me.
So with all that brass cutting process out of the way, I'll form the head. I'm really happy with the way the head turned out. Even though it's 3D printed, the rack motion is actually very smooth because of that double herringbone gear design. And I tried to use as much of the original hardware from the helping hands, including the locking mechanism and all the ball joints. Now let's use some of those other ball joints to produce the links that will connect this rack to the object you're trying to animate. Sadly, the main bar of the helping hands is a little too long to be useful. But if we cut it down, that narrow section in the middle can be glued right into the magnifying glasses connector to make a shorter link. Then we cut the remaining piece of that long central link even shorter.
Ooh, hot, hot, hot.
And combined it with the ball from this alligator clip to form the weakest link. Dun, dun, dun. Now we can assemble the links and put the last of the alligator clip sections at the very end. Finally, we can try out the whole system. It seems to be working. So the great thing is that basically works. I started using it, and I will say that one of the issues is that those links, the action is a little bit crude on them. Edu Puertas has a great video about these things, which I will link, where he basically says, "They are not balls, they are potatoes." So what we'd like to do is build some links that have both a smoother action and are both physically and visually lighter weight. But why does that matter?
It's time we talked about the dark sides of using one of these rigs. Yes, you gain the power to let your characters fly or carry coins, but you have to face the dark side. You have to edit every frame to remove the rig. Large isolated areas are trivial to remove. But in this shot, the rig is very difficult to remove because it and its shadow overlap the character in many locations. Small changes in rigging can save you hours in post-production. Do not overlook this.
First, I tried these ball head screws. Sadly, they have this annoying ridge along the center line. And even after sanding off that, they ended up more blueberry-shaped than spherical, so that was kind of a non-starter. Then I tried these solid brass beads I got from China. They're a bit camera shy. Sadly, I couldn't find these beads with a larger central hole. So you either need to have a lathe or a drill press to drill them out. Boy, does this violate the no power tools rule. Or you can only use them with tiny wire links, which might be useful, but is not exactly what I was aiming for. But after a lot of false starts, I actually found a link system that works. I got these beads on Amazon. They're brass, they're spherical, and they have a reasonably large hole. But I initially thought they were unusable. You see, these beads are not solid. They're just thin shells of brass, but that turns out to be their superpower. Now, brass on steel for the joints is great because it won't gall. But the downside is that brass is extremely heavy. But if you fill the bead with 2-part epoxy, you get a strong, lightweight epoxy ball with a brass skin. And a big mess. There's gotta be a better way. Then you can glue the rod in and clean it up. Once the epoxy is a bit harder, you can clean it up with steel wool. Then I cut the rod to length and use a drip of CA glue to glue on this 3D printed end effector. I made a number of different styles that come off at different angles. And in no time, I've got all kinds of links ready to roll.
Hey, we're gonna do this. Wow, that is big.
Is this gonna be hot?
Oh, hot. Is this thing on? Feels pretty good. It's not as heavy as I thought. Oh, All right, bring in the machine. Let's do this. 3, 2, 1. Whoa.
Next, let's slim down these enormous clamps. The clamps are punched out of sheet metal, and the side where the punch went in is smoother. You want to make sure that side is against the ball, not this other side with this vicious burr. You should probably deburr this for better gluing, but I guess it's kind of optional. Then I just epoxied on this nut and washer, which both reinforces the weak center of the clamp and lets me use this much smaller screw. There we go, smaller and stronger. Win-win. So I reworked the links and I updated the clamps. Is there anything I didn't mess with? Have you met me? Of course I kept messing with things. And so the next thing I mess with is the base. Now, it would be nice if the base were denser and smaller. And so I looked around for various things that could be used as a dense, small, uniform building block, and I decided on the 1, 2, 3 block. Now, these are used by machinists, and I had some around already. And the nice thing is that the cheap versions of them are only like 2 for $18 on Amazon. So you can get them cheaply, you can mount to them, and they're fairly dense. I actually tried a number of different mounting systems, including this very basic one. But my favorite turned out to be this one, which gives you vertical control. I even designed this 2-necked monster that lets you coordinate 2 objects at the same time. So with all of these rigs built, let's try deconstructing one of those shots you've already seen. All right, that's a cut. Let's have a technical breakdown of how this shot was filmed. First, we'll turn off the rig removal. The frames were all shot on this Canon Rebel T5 that I got on eBay, using this Nikkor 55mm macro lens. Dialogue was recorded using this Zoom H1N, with a dead cat to cut down on workshop wind noise. The main light source are these 2 Viltrox bicolor LED light panels. Over here, I record each of the frames using Dragon Frame 4. Now, to fend off any additional questions that I know are coming, this is how we recorded the behind the scenes. We filmed this behind the scenes using an iPhone handheld, running Filmic Pro Legacy, and shooting at 4K 60 frames a second. And that behind the scenes is shot by a similar iPhone setup, also running Filmic Pro. I assume that answers all your questions about how we do things here. All right, that's a cut. Don't pay attention to all that super fancy stop motion stuff. Like, almost all my stop motions up until this point have been filmed just on my phone. But it is true that if you start doing it a lot, having your phone trapped out in the garage for multiple days is not a great option. Now, trust me, if you're doing a lot of commercial stop motion, you need to invest in some commercial rigs. Those things over at Kinetic Armatures are absolute works of art, and I'm not pretending to replace those. But if you need a lot of rigs or you can't afford those expensive rigs, then I think where I ended up is actually pretty nice, especially for very lightweight things like Lego animations and stuff like that. If you're animating an anvil, this is probably not your rig either. So I guess I would call this thing a success. I mean, I'm pretty happy with the way it works, at least for small objects. And I've put all the CAD files down in the doobly-doo, as well as links to parts and all kinds of resources. If you build one, please let me know. I'd be psyched to hear about it, see some pictures. If you have questions, feel free to ask. Happy stop motioning.